This demonstration will show the current status of the TBFM replay capability that Mosaic ATM has been working on for the last few years. We have been able to record swim data, and this is both the TBFM swim data as well as the SFDPS swim data, and combine those together. They are fed into a backend database, and then the display capability reads from that database and displays the information in a web browser display that has been built to emulate the TBFM displays as much as possible. So you can see here, for example, that we have an emulation of the TBFM PGUI, and also we have an emulation of the TBFM TGUI, and we have implemented a number of the different types of panels. For example, the F1 panel for status and schedule, and for example, the F9 panel for the timeline setup. We have the ability to make changes to the length of the timeline, the filtering of the timeline. We can also open saved display files and then apply those, and then that will change the orientation of the timelines. If we can get access to the actual timeline setup files that are used in the deployed TBFM, then we can import those into the database so that the same display files that are used in the field could be used also in the TBFM replay capability. Now, that being said, as you noticed when we brought up the timeline configuration panel, there are some aspects of this that are not exactly like the deployed TBFM. Some things we can modify to be able to make them more exact, and we would want to do an evaluation and an inventory of what the different adaptation elements are, and meter fixes and different selections, so that we can make sure that we're accommodating those things that need to be accommodated. And on the topic of adaptation, we do read the adaptation for TBFM to be able to configure the displays and the capabilities. So that is also something that is needed to support the TBFM replay capability, but it also allows us to remain up to date with whatever the current adaptation is. The recorded data that is stored, we have an additional set of widgets up here at the upper left that allow us to select the date that we want to play back. And you can see that some of these boxes are highlighted. This is an indication of which days in the database have data available. So right now, this database that I'm connected to has about July 22nd to August 11th. And so if I want to take a look at the 3rd, we're about at 1700. I've selected the Charlotte setup, and when I push play, now it's starting to pull data from the database and play back the scenario as it occurred from the historical event. And I can use this slider bar here to speed up the playback rate. I'll just set it to 5 times normal speed, and now you can start to see those flights move as they approach and arrive into the Charlotte airport. We also then have coordinated the TGUI information, so we have the same speed. It's synchronized between the PGUI and the TGUI and the ERAM display that I'll show in a minute. And so this is showing the STAs, the ETAs, and these are updated according to what we're getting from the TBFM feed through SWIM. We also get information to populate some elements of the F1 panel that would give information about, for example, the configuration or the arrival rate, for example. Now, interestingly, the swim feed does not have all of the information that one might want to be able to use. For example, the scheduling matrix, the separation matrix, is not included in the swim feed, and so we're not able to include that in the replay capability yet. Let me turn now to the ERAM display. Again, this is an emulator of an ERAM display that we have developed that is running in a browser. You can see that we have the targets, and we can bring up different elements of the background map, for example, high sector boundaries and jet routes to be able to give some context here for what you're seeing on the ERAM display. And we also have the ability to select then different sectors within the ERAM display for Atlanta Center. And in this case then, as you can see, the display takes some time to buffer and receive the new updated information, and then is playing back that information. We do have altitude filters implemented in this display, so you may see targets disappear or appear in the middle of a sector, but generally that's going to occur because they are descending below or climbing up into the altitude range. Now you can see here on the right hand side that we do have the sector meter list for each of the appropriate sectors. And I've selected a sector here specifically to try to show one that includes both a meter list for Charlotte as well as a meter list for Atlanta, so that you can see that we have the ability, even though we are looking at just one of those situations on the PGUI or the TGUI, when we go over to the ERAM display, we're seeing all the traffic that is in those sectors, and on the meter list, we're seeing all the things that the controller would have had to consider and deal with. We do have the meter fixed time, the scheduled meter fixed time. We indicate the frozen meter fixed times with those that are underlined, and we have the countdown timer also shown in the column here on the meter display. I have restarted the playback here at about 17:30. I want to track a particular flight and show a correlation between what we see on the display on ERAM with the meter list. This flight here, JIA 5304, we can see here in sector 42, and we see it here on the meter list with a meter time of 1743 that is not frozen. And you can see, in fact, that it's already changed to 1742. Again, it appears that these times are not set to freeze at this point. JIA 5304 is at 24,000 feet, which is at the bottom of the sector limits for sector 42. And so very shortly what you'll see is that flight will descend and it will disappear because it descends below the limits of this sector. Now I've pointed up here to the altitude limit display, and I do have to admit that list of altitude limits there doesn't actually change when the sectors change. That's one of the things that we need to update. Okay, you saw that flight disappear. You can see that we still have the meter time here, but we need now to go to sector 44. And because now we've gone to a low altitude sector, there's JIA 5304. I'm going to bring up the low altitude boundaries, zoom out a little bit so you can see the context of where we are. Here's Charlotte Center. Notice that this aircraft is going backwards, and actually what we found that in fact this flight was put into just one turn in the holding pattern as it was transitioned from that one sector to the other. The meter time is adjusting at that point, and you can see it's up at 1750. The flight disappeared for a second because it went out of the bounds for that sector, but came back, and you can see that it's now continuing in towards Charlotte. You can also see the other flights here, American 1929 and 2553 are the ones that are shown in the sector. EJA 522 is not shown because of the altitude limits, but will be coming into the sector, as you can see by the time there. So American 1929 just disappeared because it descended below the altitude region as it was going into the terminal area, but you continue to see American 2553 and GII 5304 as they travel in towards the TRACON boundary for Charlotte. American 1929 is now dropped off of the meter list. You can see these other two flights continuing on in. And just for validation, we looked up the FlightAware track for this particular flight here, the GIA 5304, on this particular day of August 3rd. And in fact, you see that loop right there in terms of the holding pattern that we caught as we were looking at that flight. And at this point, American 2553 has a meter time of 1747. It's now 1747, which is right when this aircraft is crossing in. There is EJA 522 entering in to this sector now with a meter time that's continuing to update again because these times are not frozen. And you can see the display countdown timer updating in each one of these cases. What I'm going to show you now is a demonstration of how quickly the data is collected and made available for replay. We're looking at Charlotte again, and you can see that we're zoomed in largely on the terminal area. You can see some of the arrival flights that are shown on the PGUI display. We have a JTL 1027, for example, here that's looks like it's about to enter into a downwind for one of the northbound runways. And we are at about 12:43 in the replay time on the 2nd of September. In fact, the actual time is about 12:45, and we are viewing this replay just 2 minutes after the actual events occurred. So I can bring up a live display, for example, of what is going on at Charlotte currently. And you can see here, for example, UPS 5541 at this point is on final for what is probably 36 right at Charlotte. And when we go back to the PGUI, you can see that UPS 5541 is a little bit further out from the airport, about to finish its turn to final for that 36 right runway. And so you can just see here that the time period between the data actually occurring, the flight operation actually occurring, and the data being available for replay is very short. And specifically, all of this happens automatically. There is no manual process, there's no overnight process, there's nothing that anyone has to do to be able to make this data available. It's all harvested and collected automatically, put into the database, and then is available for replay immediately thereafter.